universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hey, hello, and welcome to SkyTour Radio. This is Mark. Down there we have Tara, and we have Amanda over there, and Daryl down there in the corner. It's a story of a lovely lady. Remember the Brady Bunch? Anyway, welcome to It's Really Live, a live show of SkyTour Radio.
Marsha.
That's it, exactly. That's right. So I just want to say hi. How you doing, Amanda?
I'm well. It's been a minute. I hope everyone out there is well, and welcome back.
Yeah, fantastic. Yeah, well, it's just been a combination of things. I got a lot of things going on. I had to film for an A&E show. I had to do other things. I know it's like, oh, what a life. Yeah, no, there's a lot of work that I have to do to actually pull that off. And then we had Easter that came up in the middle of all that as well, you know. But one thing I didn't let slack was trying to get our streams in, because the streams don't require a script and don't require organization between 4 different people. Okay, to try and get it and pull it all together, including Bill, our wonderful esteemed producer, who is just phenomenal and who supports us in every way. And one thing I want to mention, in the coming weeks, on June 4th, we're going to be at Pine Bush, New York. The UFO Fair and Festival is going to be going on June 4th. And I think that's the Saturday, but the 3rd, there's talks in the evening. So get your tickets from the Pine Bush UFO Museum website and check that out. It's going to be great. Additionally, I'll be in Roswell, New Mexico for the Roswell Daily Records amazing festival of UFO sights and sounds. And I'll be speaking there as well with a bunch of really, really good people, top names like David Marler and so forth. And so check that out too if you get a chance. And then finally, if you have never been and you want to try and go, you might want to consider the Mutual UFO Network National Symposium. That's the MUFON Symposium happening in Daryl's neck of the woods in Denver, Colorado. So Daryl, I recall being in Colorado to speak one other time, and you didn't drive the 10 minutes to come see me out there and to say hi. So now you have to. I don't know how far Denver is from where you live, actually.
It's an hour away.
No, actually, that's pretty far considering I was in Centennial, which is closer.
I will try. I can't promise anything.
Not expecting.
Will they charge me admission to get in?
I'll see what I can do about that. I don't know if I can do anything about that, but if I can, I will. But I don't want you to drive all the way without knowing that. I'll let you know ahead of time because maybe I can.
Well, we'll see.
Yeah, I don't expect you to.
I'll say this: if they don't charge me admission, I'll buy dinner for everybody.
Ooh.
Everybody? Do you know who everybody is?
Well, I assume it's going to be about 4 or 5 people.
Okay.
I mean, you, Marianne, Tara, and I think Bonnie may be there.
Yeah, Tara's not going to be there, though. Or she's.
I don't get to go this year,
And the lady from the MUFON show.
Oh, that would be Katie Grabowski.
Katie. Mm-hmm.
Yeah.
Katie.
Yeah. I talked to her
Check
yesterday.
her out Tuesdays at 8 p.m. Eastern here on KGRA-DB for MUFON What's Up.
She's
actually our good friend Martin Willis, who also has the show here on KGRA Podcast UFO. He just dropped by chat. He was last week's guest on MUFON. So
yes, he was.
Stay tuned here for all the greatest shows, all the greatest content.
Yeah. I knew there was a plug or two in there.
Did you miss me?
Yes, and he was aiming. Yeah, this is great. So Yeah, the Move on What's Up show is great. Okay, and Marianne that Daryl mentioned is now she's got a show called I Detective. And
That's Wednesdays at 6 Eastern p.m.
I don't even have to say it. This is great. Thank you, Amanda. Amanda knows because she actually helps to produce that show. So that's really, really good. But
I would warn you too. I'm a shorts and t-shirt kind of guy, so don't pick a restaurant where you have to dress up because I'll be dressed down.
So will I. Just so you know, I don't. I'm not a. I don't wear a suit unless I have to.
Oh, you gotta wear comfortable clothes when you're going out to eat, and don't fill up on bread or salad.
Oh, that's a good point.
For the high price items.
That's a really good point. You know.
Well, in July it'll be summer by then, and you'll want to wear shorts and t-shirts anyway.
Mm-hmm.
I hope it's summer here in July.
I saw someone wearing shorts and a sport jacket with a tie. I guess that was a look, right?
The newscaster?
Yeah, probably not my look though. Yeah, but that's the look at it. This isn't Zoom anymore, dude. You know?
Didn't Van Halen have that look for a while?
Yeah, and so does the guy from AC/DC, right?
Okay, maybe that's what I was thinking.
That's who you're talking about.
I can see someone with shorts and a jacket dancing on stage.
Anyway,
back to the show.
This is all wonderful. Let's say we're all catching up, guys, because we haven't talked to each other very much. Between we have. I mean, Daryl and I stream a lot together, and Tara and I talk a lot, and of course, she's instrumental to helping SkyTour live streams observatory out in the desert. And Amanda, I haven't talked to you in a while, so hopefully you're doing okay as well.
I am.
That's
glad
good
to be back.
Yeah. And speaking of SkyTour live stream, this is you, Tara. We are in the process of we're nearly done with converting the SkyTour live stream observatory into a 501c3 organization. The reason we're doing that is because we want to be able to take advantage of potential educational grants or outreach that might be available to us. And they don't give to individuals, they give to organizations. And this is what I meant when I've said this to you guys many, many times before. SkyTour live stream is no longer an I, okay? It's a we, and I'm okay with that because I don't care who says it as long as somebody does, right? We have Daryl out there that makes this beautiful commentary on the objects we see in SkyTour live stream, and he has wonderful, mythology and things that he throws in. He likes to add in details about star names and things, you don't forget those things. And so I don't know those particular things. I'm an astronomer, so I can tell you all about planetary nebulae, all the way down to some of the chemistry. But Daryl's point of view is a very different point of view, and his is from an observational astronomer, and it's very different. It's actually very refreshing. So if you haven't had a chance to watch SkyTour live stream, please join us. Okay, we are out on clear nights. If it's clear in Arizona tonight, I may do a stream. And you have to look for your notifications because, right up until 5 minutes before the stream last night, almost about 10 minutes, which we did last night, I didn't know I was going to stream. And the reason was because we watched the wind. If the wind is too high, if it gets above 15 knots out there in the desert, well, then I don't open because that means stuff can blow in and it also moves the scope imperceptibly. So when you're taking a long exposure of things, long for us, meaning 20 or 30 seconds, the telescope could be moving around a little bit, and then you get all these big, blurry, weird lines instead of stars, which is an art project in itself. But, sometimes you want stars, right?
The imperceptible becomes perceptible with a time exposure.
That's exactly right.
Weather Underground tonight says clear in Arizona, though it may be a little breezy again.
Yeah.
10 to 15 miles an hour.
Which is less than yesterday. We had gusts up to about 27 to 28, top end around 30.
Yeah.
And I don't open if we're above 20 realistically. But those are gusts. If it's steady winds under 17 miles an hour, I will open. Shh, don't tell anybody.
Yeah. And it's Galaxy season now, folks.
Which is the name of our show today.
Yeah.
The Galaxy season show.
Hey, another
What a
plug.
coincidence.
You get an eyeful if we look at Galaxies tonight, folks.
Yeah, and you'll see some tonight because Daryl's going to do a deep dive for us in a little while. Tara's going to ask us some cool questions. Amanda, you can always ask us anything you want at any time. You know that.
Oh, I will.
And she will.
I won't even wait for a break in the conversation. I'll just jump right in.
Well, that's okay because you know me. You know that I come from a performing background, so in my background, you don't leave any dead air, right? And so dead air is a killer, especially if people just listening, and all of a sudden it goes quiet, and they're like, what's going on? They just,
Dead air catches my ear more than an explosion. The silence is deafening, especially on live air. Yeah,
that's right. So we try to keep the dead air to a minimum, even if you're just adding what we call a pregnant pause in a conversation. You go, and there's your pause. But there was a vocalization. There was a and that's just automatic. I'm not doing it because I'm saying, okay, insert pregnant pause here. Beep, that's not what I'm doing. But it's just automatic, but doing these shows is so much easier than having to do visual performance. Like I used to be a magician. I would do magic tricks. Mm-hmm. So I had to know the trick. I had to know the angles. I had to know the audience. I had to keep their attention. I had to say words at the same time, all while trying to foist off a little prestidigitation on them. And that was far, far more difficult than ever doing any of the television or radio or this type of stuff that we're doing now. So this is kind of fun time, and tonight's script consists of a few bullet points, a couple little sentences here or there, but we know where we're going. We're talking about SkyTour Livestream, our wonderful Desert Observatory. This radio show is an offshoot of that. And a lot of the things we photographed, even in just the last couple of weeks at SkyTour Livestream that we streamed, with Daryl, was or are galaxies. And once Orion sets and once we lose the winter sky, it's like, oh, now what? You can't really see anything in the sky. You see this beautiful Orion in the sky with Betelgeuse and Bellatrix and Saiph and then Rigel and the belt of 3 stars, Alnitak, Alnilam, Mintaka, these beautiful stars. It's like, wow. And then they're gone. And you're left with the stars of Leo with 1 star, Regulus. Okay, it's kind of bright. And then Spica, there's a sort of bright star coming up. What else is there? Well, you got Arcturus and then what do we do? Well, what's not visible is the absolute abundance of beautiful galaxies. And galaxies are interesting objects in the universe because these galaxies are like island universes all their own, right? Daryl, you've seen our island universes, these galaxies. We took photographs of them last night that were pretty stunning.
Oh yeah. Of the 1,000 brightest galaxies in the sky, 3/4 of them are spread across the springtime sky from Ursa Major down through Canis Venatici and over Berenices and down to Leo and Virgo.
Yeah.
And it's galaxy season is what it is. And hey, that's why we're here tonight.
Yeah. And for you, Amanda, a Mesher Marathon would probably spend an awful lot of time in this part of the sky.
Yeah, I guess I missed March.
Yeah, but that's okay. I probably wasn't up for it at that point, but you know what? It's okay. She's
one day.
I prompted you a couple of times.
Stop talking down there. I don't tell her that.
Well,
he didn't mean it. Just don't ignore him. He doesn't know what he's saying.
Daryl's fatal flaw of honesty. I know how you hate that.
It's okay.
You'll miss me when I'm gone.
He did mention a few times, but it just was inconvenient. I had a project to do or something. I just couldn't do it because it meant I'd be up for a full day without sleep in order to do it right, and I couldn't afford that at the time.
Wasn't meant to be.
Well, I know, Tara, but honestly, it was.
Would have been.
It would have been fun, and we will do it sometime because it really is a good time. I know how much fun it can be.
I'd like to be part of that at least once, just to say I did it.
Oh yeah.
That's pretty cool.
Yeah. Well, you're very familiar with these types of things, right?
I wouldn't say very. I wouldn't use that adjective, but
yeah.
Names ring a bell every once in a while. Yeah.
Yeah.
That's another merit badge for you.
Yeah, that's right.
Nebulas ring a dumbbell for me every once in a while. Oh.
Yeah,
Nebula.
okay.
Come on, I'm trying.
You did a nice job, though. Yeah, that's true.
Well,
You earn a rosette. So, that's this right here. That's the rosette. She earned the rosette. So when we talk about our galaxy, right, we've talked about this before. This is what our galaxy looks like from the inside. There it is. Okay, we're actually looking through nearby stars to the more distant spiral arms of our galaxy. This is the Sagittarius Milky Way that's on the screen now. And that's looking more toward the center of our galaxy. Now, the interesting thing about this photograph is it was taken just after sunset. And even with the orange of the sunset, you can still see the Milky Way in this photo. That's how dark it is out there at this location. That's really spectacular. But the point here is we're actually looking at this dark dust that we see in our galaxy's central core. You can see it right there. It sits in all the spiral arms that are all around the galaxy. And our galaxy is a spiral type galaxy with some modifications of recent years. We'll talk about that. But also in our galaxy, we see all this stuff. You see these beautiful nebulae. This is hydrogen gas that's actually being made to glow by nearby hot stars that have very, very high-end ultraviolet radiation that causes the hydrogen atoms to glow. There's a lot of dark dust. Yeah.
Cave Nebula?
This is the cave. Very good. Yeah.
Sorry, I can't help myself.
That's what I like about him. You see, that's what I like. See, he just he always keeps on top of things, which is great.
It's not my first rodeo.
Yeah, right. So the Cave Nebula, for instance, yeah. And, of course, then this one, which Tara recognizes, I'm sure.
Is that the Pleiades?
Yeah, it's very good. It is. And this gives you an idea. These are the hot stars of the Pleiades in our galaxy are actually moving through dust, not hydrogen gas, but dust. So they're not causing hydrogen to glow. They're actually causing dust to reflect or scatter their blue light, which is why the dust looks blue. And the way that works is, and just a quick thing here. This is not meant to be like an exhaustive discussion about this dust, but this is what the dust actually looks like. All right. It has all kinds of chemistry on its surface in the form of ices, and it has a silicate core. All right. And then we have methanol and formaldehyde and carbon monoxide, etc. And this material gets driven off by ultraviolet light and forms a slurry of planet and star building materials. All right. And that's what you see in these nebulae. Okay. Like in here in the rosette that we showed earlier, you see those little dark snaky lines. Those are dust of that type, interstellar dust. Now, if we looked at that dust up close, a single grain might look like this. But this is a combination of many, many millions of grains, right? And they all form a larger dust particle. But these grains are really, really tiny. And in the interstellar regions where they're in the nebulae and where you see them glowing, okay, that's thank you, Justin. In the place where you see them glowing like that, and where you see this blue dust that is actually scattering the starlight, like in the Pleiades here, this dust here is literally only about as long as the wavelength of blue light. So it's somewhere around 100 nanometers, more or less. And that's a billionth of a meter. So 100 of those is what that length of the tiny, tiny piece of dust is. And there are many, many trillions upon trillions of dust particles out there. This is stuff created in old stars as they died and were sloughing off their outer atmospheres and going supernova. It's just an amazing thing. And in our galaxy, when we look at the formation of galaxies, all of the material that we see in the galaxies, is made of this stuff. All the stuff in our periodic table, right? We're not going to go through the periodic table because that makes people have agita. It's like, nah, the periodic table again. They don't want to hear that. But everything inside of you, everything that you're made of, Amanda, and of course, Daryl and Tara, was once made in the heart of a nuclear furnace inside a star. And that's sort of that's a reckoning moment for a lot of people when they realize that everything they are made of was once formed in the heart of a star at one point, right? And so the stars were formed, and the clouds of stars in the galaxy are formed. And, no one asked the question, where do galaxies come from? Where do they come from? How do they rotate? Do they rotate? What do the stars inside the galaxy do? And when we do Daryl's Deep Dive, we're going to actually see a lot of these galaxies that we took with our telescopes. So it's actually really interesting how this all works. There was if you look at our solar system, Mercury goes around the sun once in 88 days. Pluto takes 250 years or more leisurely traveling around the sun. So it's going a lot slower around the sun, but it's farther out. Well, that kind of differentiation of the speeds is what we fully expected in the galactic world too. The stars near the center would whip around really fast, and the stars outside would move around, in a much slower way. Well, it's not exactly that way. It has a curve to it, so it's called differential rotation. The galaxies do rotate differentially, meaning the stars near the center do go around a little bit faster. The stars on the outside go around a little bit slower. But what happens is galaxies seem to, by and large, form these spiral arms. And we've taken a lot of photos. Daryl, you've seen these with our galaxies with all the spiral arms that they're showing, and they actually look rather interesting. And there's various kinds of spiral arms.
Yeah.
Yeah.
Well, and sometimes there's no spiral arms at all.
That's right.
Elliptical galaxies. When we look at M87 in Virgo, the big one with the ultra massive black hole in the center, and we see the plasma jet sticking out the side, it's an elliptical galaxy.
That's right.
And it's huge. It's the biggest galaxy in the Virgo cluster.
Yeah. And we are heading toward it, and then the whole cluster of the Virgo galaxies is heading toward yet another thing called the Great Attractor.
Yep.
Oh, what's that?
But spiral galaxies are pretty.
They are.
That's why we look at them.
I have a question.
Yes, Tara.
Are the spiral arms created by the momentum of the galaxy spinning? Or
That's an interesting question.
where
Now,
are they caused from?
There's two causes to the spiral arms potentially in a galaxy. Notice I say potentially. This is science, but it's not fully dogmatic. We don't know this for fact. We know that there's the potential that there's certain elements to creating the spiral arms. I'll give you an example. Because of differential rotation, sometimes galaxies interact with other galaxies. And as they do, the gravity of this galaxy can pull on this galaxy in such a way that it actually starts a ripple effect in this galaxy, a ripple effect of gravity that actually causes motions to occur and actually starts causing clumping to occur. Well, when things clump in a galaxy, they have more gravity, so they attract more things. And if they're already moving, then it's been noticed that structures within galaxies tend to head toward a spiral structure. We even see this with forming planetary systems around other stars. We see this clumping kind of tend to make early on some spiral structure, but then it evens out over time. With a galaxy, though, several different things can happen. Okay, once we see that spiral arms form in a galaxy, they can maintain themselves through a variety of means. One is this one. Let's suppose that something disturbs a galaxy, and so star formation starts and makes this beautiful clump of bright blue, hot young stars. Well, because of the differential rotation, there might be you might expect, and it does, you might expect that they will drag out as they're being rotated around and form an arc. And indeed, that's one of the things that is thought to happen. All right, that's one way, and that's just from the momentum and the structure of the galaxy and that clump of stars. All right.
Yeah, conservation of angular momentum.
That's correct. Now, Now think of it as this: star formation gets sheared off and sheared around into spirals due to this differential rotation. So that's one way. The other way is a little bit more complex. That's called density waves. Ooh, density waves. Now, what's a density wave look like? Well, you're in a helicopter overhead looking down at a highway. Well, we got a traffic down there. It's 5 o'clock, and I see a giant cluster of cars all stuck in the same place. And I see a red car coming in from the left, and it's slowing down to enter that traffic jam, but then it finally makes its way out at the end. So the red car gets through the cluster, right? Gets through that clump and moves on. But the clump is still there. That's a density wave. Okay. And that's what we're talking about in a galaxy, potentially because of a perturbation that is a disturbance by a passing galaxy or within the galaxy itself through some type of cataclysmic event. A spiral arm can be formed by this ripple effect where the stars get sheared into this spiral structure. And the standing, it's like a standing wave in a sense, meaning that it's like a perpetual crest of a wave and a perpetual trough in between the spiral arms, and then a crest of the wave. But what happens is the stars pass through the trough and through the crest and keep on going. It's a density of dust and star formation, but overall, the stars move on through. And it's possible that spiral arms in many galaxies haven't lived for a long time. That might be that the spiral arms that we see in galaxies are transient and may not be there in the future. I mean, we're only 13 billion years in. And, we've gone around the center of our galaxy 20 times with the sun. All right, only 20 times since 4.6 billion years ago. That's a fairly long time. The galaxy was probably around way sooner than that. Okay, so any spiral arms in our galaxy take an awful long time to change their morphology, change the way they look. So we have this shearing thing where stars form, and then because of the differential rotation, get dragged out into a spiral structure. It's a natural formation. It's not something that's magic. It's a natural thing that happens. Okay, in the same way that when water goes down a drain, it doesn't go down evenly. Sometimes you'll see ripples in that water as it's going down, right? Well, those ripples are the crests and troughs of a galaxy's spiral arms, effectively. It's the same type of thing, and that's the shearing thing that does that. The density wave is a different one. Yeah, go ahead.
I have a question. Do the gravity waves, do they themselves revolve about the center of the galaxy? And if so, are they moving faster or slower than the stars?
Gravity moves at the same relative speed.
Density waves. I'm sorry.
Density waves. Okay. Density waves in a galaxy, I actually thought that's what you meant, and I actually said gravity waves to answer your question, but I knew you were talking about density waves. My bad. I talk about getting old here. Density waves. Huh? I couldn't hear you. Density waves in the galaxy, they pretty much outline the spiral arms. So although they're moving, they are actually moving at a different rate. All right. And when you watch how they move, or watch how stars move, you see that the stars are effectively not subject to the density waves. The density waves are just areas in those troughs and crests where star formation is occurring, mostly in the spiral arms. That's why spiral arms, by and large, look blue. So they're moving, but they tend not to be moving as fast as the stars are orbiting the galaxy. They're moving slower. All right. And it's interesting because they're like a ripple, and the ripple is slowly moving, which is why they think that density waves in some galaxies can be set up to be very, very tight spiral arms and somewhat loose spiral arms. Yeah. Some of those can occur from different reasons. Like one of them is that shearing thing I told you about, where the stars can form, and then as the galaxy rotates, the stars get left behind in the outer area because they're moving a little bit slower, tiny bit slower. But over time, that drag gets a little bit more, and you can actually start to see that shape form. And then inside, they move faster, but by very little. Again, the galaxy is mostly rotating like a rigid disk That's the key. Okay, we would expect speeds to be very different if it was actually using proper kinematics that we understand, the rotational physics. So that said, when we watch this differential rotation shearing these gravities out like that, or shearing these galaxies out like that, that could be responsible for what we see in many spiral galaxies. And density waves don't actually have to play a part in that, you see. And different galaxies show that. Okay, for instance, the Whirlpool Galaxy. The Whirlpool Galaxy is a wonderful galaxy that we know and love. We actually shot it just the other day. And let me just show it to you right here. Okay, this is the Whirlpool Galaxy, right? There it is, right there. Okay, the Whirlpool Galaxy that you see here, this is and I'm in Photoshop with it, or I processed it. The Whirlpool Galaxy, these spiral arms look like, from the understanding of the paper, that they look like the result of this galaxy interacting with it. And that maybe the perturbations caused by this whole separate galaxy at the tail end here. Now, again, we're seeing a snapshot. These things have been moving by each other, probably orbiting several times over the last several hundreds of millions of years. Okay. And when we look at this, we're seeing a galaxy that's in flux. You see this stuff out here. There's all kinds of stuff out here that we don't know what that is. We don't know what this is out here. I say we, meaning you and I and everybody else, right? But then you've got stuff down here, all right, all along here. These are all star clouds. These are all clouds of stars. This galaxy looks like it passed too close to this one. It looks like this galaxy may have caused this galaxy's spiral arms to form, and now this galaxy's mass is ripping it apart. Now, there's something interesting we've always said, and Daryl was talking about this yesterday in SkyTour live stream when we talked about this. When you look at this galaxy and you look at this galaxy, you feel like you're looking at them on a plane, right? But you're not. This is a case of a 3D universe, remember. So we have, if you look at my hand up there in the corner, we have this is the main galaxy, but then we have this smaller galaxy, which is back here. It's actually at a distance further away from us than this galaxy here. And as such, this part right here, this part of its disk, of its spiral arm that you see here, you notice how it seems to be pointing. It goes to a point here to point at that. That's happening because this one has gravity of its own and it's pulling on this, but it's further away. So from the top, it looks like this, or from the side, it looks like this. Okay, this galaxy is actually, this galaxy, the main galaxy, has actually got a warped disk that's pointing down at this other galaxy. And that's pretty cool.
It's awesome. It's very cool.
Yeah. Thanks, James. It does look 3D, James. He's right.
I like images like this. I don't know if it's like so many constellations and nebulas. You're supposed to be able to see something, and I can never see any of these things. But maybe it's just because it's like such a basic kind of shape. It's very easy on the eyes. You don't I'm not looking for a bear or a rabbit or a person holding something. It's very easy on the eyes, but when you think of how much is actually going on, like how much is packed into this one image, it's just it's weird when you look at it from different angles. Like something so simple is so complex, and I love images like this. They're gorgeous.
Why they call it the Whirlpool?
Yeah, well, there you go. It is. I think it's a relaxing image on the eyes.
Well, it's straight on. That's what's cool about it too.
Yeah.
Face on, we call that when it's looking like that.
Yeah, almost like not a mandala, but I know you were saying with the gravity, it kind of arcs at the top, but the symmetry, it just it looks natural and it feels natural, and I don't know. It's very, very appealing. I like images like this. I'm a basic person. What can I say?
Yeah, it's awe-inspiring.
It really is. It is a beautiful image.
Yeah.
you know. So, obviously, when we look at a galaxy like this, we tend to think, wow, we have so many stars that we're looking at in this galaxy. And of course, as an astronomer, and I know you feel this way too, Daryl, to some extent, I think, and I know you do as well, Tara, and probably you, Amanda. You look at an image like this and you think, I can't believe we're not looking at other civilizations right now.
Right. Mm-hmm.
There has to be other life out there. And now the hardcore people will say, well, there doesn't have to be. Well, that's true. But if we're any measure, carbon is the fourth most abundant atom in the universe, next to oxygen, helium, and hydrogen in that order. So clearly, a carbon-based life form is going to be very common in our universe, and that commonality, that's kind of important because it speaks to the fact that the universe being full of carbon means that there's probably going to be a lot of carbon-based life forms out there that use oxygen to get energy because that's the next most abundant element. And the nice thing about carbon and oxygen is they take many forms. They can be connected in very many ways. In fact, in this table here that everybody hates, look where carbon is. Carbon is up here at number 6. See, right up there. All right, number 6, and directly below it you see silicon, Si. And people say, well, what about silicon-based life? Can we have silicon-based life? Well, you might think so because everything in that column chemically, all right, are related to each other. So the next most likely element in the entire table would be silicon. Not beryllium, not oxygen, not nitrogen, but the next one down in that column. And that's what we're looking at when we look at the periodic table. Those columns mean something. So the problem with silicon-based life, and we've talked about this before in SkyTour Radio, silicon-based life can't exist in all likelihood. And the reason is because silicon makes very robust bonds. And when it bonds with oxygen, for instance, SiO2, that's sand. So try breaking apart a sand molecule, okay, those molecules of silicon dioxide, right? The bonds are very tenacious, and they tend to form crystalline structures. And that tends to take us away from life-bearing capability and the flexibility required by life-bearing chemistry. So,
as we know it.
Okay, we can always say
we've done this before. No kill eye, all that. The Horta in Star Trek.
Yes. Yes.
Maybe it's just not life as we would know it.
Well, yeah, but then our definition of life gets challenged, and of course, it's challenged anyway because we don't really know what it is. But I think that if there's life out there, it's most definitely going to be based on carbon. I'm a bigot. Okay, I'm a carbon racist. Okay, you want to say it? Go ahead. I believe that carbon-based life is probably the norm, not the exception. In fact, look at us. Everything on this planet is carbon-based, as well as the bilateral symmetry. We're the same on both sides, right? So being that we're the same on both sides, okay, that means that we're symmetric on both sides, probably based on our DNA strand when it was unzipped, sent to another cell structure, and zipped up with another complementary half. That's a symmetrical building, 1 for 1 amino acids. Right?
Helix is kind of like a spiral galaxy.
Yeah.
Amino acids, you took the words out of my mouth. And
okay.
that's the one thing that really supports what you're saying. I mean, they see amino acids or precursors to amino acids out in space.
That's right.
We see them in carbonaceous chondrites and stuff like that, meteors.
We do. Carbonaceous chondrites are meteors, guys, just for those that don't.
Yeah.
But see that's important to follow up on, Daryl, because when we talk about the fact that there's amino acids, the precursors of life, the building blocks of life, however you want to call it, we also see other things called hydrocarbons. Hydrocarbons are very important to life and the foundations of life. And those are also delivered to this planet by meteors and asteroids and comets, and have been for billions of years. So left to its own, you might say, well, then the Earth would just be sterile if we didn't have all these things dumping on us all the time. And that's not true either. the Earth makes its own pot of elements from which life can spring, and that's proven by the fact that our the experiment that we did, the Miller-Urey experiment back in 1952, I believe, they had a flask which they filled with the atmosphere of what was thought to be the primordial Earth's atmosphere at the time. Okay, and it's in this flask. Then it went
ooze.
up. The ooze, that's right.
That's
And
right.
it wasn't ooze yet. It was just
Oh,
gases. Okay, just gases.
Methane, ammonia, stuff like that.
Yeah.
Okay.
Okay. And in some cases they use carbon monoxide. Other cases they use carbon dioxide. And they came up and these pipettes brought down to a reservoir of water that was being heated. And that water would evaporate, go up the tube, and then drip down into this flask. And in the flask, that big flask, there were electrodes coming in, and there was a spark gap. And every now and then it would go, it would spark across the gap. What was the purpose of that? To simulate thunderstorms and to simulate lightning on a young planet with a primordial componentry of atmosphere. And after just 1 week, they found a sludge along the bottom of that flask. And what was in that flask? What do you think?
Ooze.
Yes, that's where the ooze comes from.
Life, right? Or
not life, no, but more importantly, what was exactly in that flask? Not exactly, because I don't expect you to know all that. But what do you think was in the flask that indicated that the Earth probably built its own life as well?
is it the amino acids?
Yes,
Or-
exactly.
Okay.
Correct. They
I was gonna
found
say vodka.
Well,
Don't drink it. Don't
That's
drink
proof
it.
humans were here. There was vodka. Yeah.
It's a beer.
Thank God you're here, Tara, for the right answers.
well, you know something though. I'll tell you this, Amanda. The alcohol group in vodka is also very important to life. How about that? Okay, so
Or to
you see,
procreation sometimes.
yeah,
It's a matter of opinion.
that's another show.
That's right.
We don't talk about that.
That's another show. We don't talk about that. He got out on bail anyway. So, no. So, the building blocks of life that were created by the Earth itself. See, so, when we look at this beautiful image of the Whirlpool Galaxy here, we're seeing an area or a place where this may have played out at some time in the past in this galaxy, and it's really amazing. And so that was, believe it or not, this whole last 20 minutes was an aside to the concept of galactic structure, but still, when you look at it, I just can't help but think that we're looking at life elsewhere. And by the way, when you look at a galaxy like this, let's say we lived in this galaxy right here, this upper one that's being ripped to shreds by the Whirlpool Galaxy's bigger mass. What would that mean for us if we were there and we were in a little spiral galaxy going around our galaxy, playing music as we did? It would take millions of years to go around the galaxy once.
2
right?
minutes. Would we have a 2-minute warning? Because
Yeah.
we'd have to run
Well,
away, I think.
I think it'd be a 2 billion year warning because of the fact that the collision literally takes place so slow. The fact is, we wouldn't have noticed. Nothing would have changed in all likelihood. We would just see, in the lifetime of a human anyway, we wouldn't notice any difference. If for instance, a civilization born right now in this region, say right there in this outer reaches of the galaxy, is going to see 2 bright spots in its sky. And they're not going to know where they're moving and where they've been moving. They're just going to see the 2 bright spots. This one probably being brighter than this one. So what's it mean to them? They're still going to survive. All they need to do is make sure that they're still on a planet that's orbiting their star. And if that star gets ejected slowly from a galaxy through gravitational tugging, then it does. There is something to be said, though, for rapid onslaught of a gravitational event. If there's such a rapid onslaught, well, then the planets could literally get wrenched away, and the star could be wrenched away from the planets, and the planets might end up in elliptical orbits, which would not allow for the formation of life. But that's, everything in the universe happens slow, slowly,
Weird.
So
Life seems to move so fast. So it's
it does. It does. There's no doubt
crazy.
about it.
Life
Life moves.
seems to find a way.
Yeah.
That's right.
This
Jeff.
hasn't been that long. You drill a few things into my head. It might not
Yeah.
be, elemental compositions or Latin names, but life will find a way. I remember
That's
that.
right. Jeff Goldblum in Jurassic Park.
Yep.
Yeah. They were arguing that the dinosaurs can't reproduce because they're genetically they're sterile or whatever. And then he takes his glasses, right? And he goes, life will find a way. And they looked at him like, you have two heads. And then, they passed on that. And of course,
Never
he was
ignore
right.
the scientist.
Never
I don't
ignore
care
the
what
scientist.
movie you're
He was
watching.
right.
Never ignore the scientist.
That's right. That's right.
Well,
Maybe that's the problem. Sorry, go ahead.
No, go ahead.
No, I was just going to make another bad joke that maybe that's what is going on with the aliens, and that's why we're being abducted and impregnated. But again, I've been hanging out at MUFON What's Up on Tuesdays at 8 p.m. Eastern too long, so yeah, I can humor you a little more.
Shameless
Well,
plug.
Is alien,
I mean,
life will find a way.
this all leads to, the notion of what's called panspermia.
Yeah.
That life spreads through the galaxy, through the universe, and that we see amino acids and hydrocarbons and all the building blocks of life out there. And there's speculation that meteorites from Mars may have hit Earth, or meteorites from Earth may have hit Mars and helped convey life from one to the other and help life spread.
Well, I like that these kind of
yeah.
things can carry all these elements that could combine with other elements in the right. But I mean, think we put Philae on a comet.
That's
So
right.
I mean, not just accidental, but what about intentional?
Sure.
That's right. Now, Philae, of course, was part of the wonderful Rosetta mission, not named after the Rosette Nebula. The Rosetta Nebula is a separate thing, but the Rosetta mission to Comet, and that particular Philae landing on Churyumov-Gerasimenko, which is known as 67P periodic, that showed that we have the technology to do this, although we did it in not too well, and we ended up kind of missing our landing, couldn't stick the landing, and the comet has so little gravity that it just bounced a little bit, but that was enough to be able to take it miles back above the comet, and then it slowly drifted back down. We're kind of bounced along 5 or 6 times before it finally lodged in the crevasse. So we couldn't get it perfect, but that's because we never realized just what the surface of a comet had for soils, if you will. That takes us down the path of going into asteroids that are actually just collections of rubble piles. Again, in the absence of any gravity, a stone here and a stone here will gravitate toward each other. And then in the darkness of space and the cold of space, those stones might cement themselves to each other because of ices that accumulate on them from material, or from the impact getting a tiny little bit of heat. And if there's any water whatsoever, or any formaldehyde or other chemistry, which there usually is, then those could end up getting cemented together as an ice particle of two little tiny pebbles. And then those are now bigger, and more will come in, and it gets bigger and bigger and bigger. And that's possibly how galaxies even came in formation. A large star cluster formed, and when a large star cluster forms, it's a spherical cluster, kind of like a globular cluster, right? But then over time, as more material gets drawn in, it forms an accretion disk. The disk structure is well known, and that disk structure is what we're talking about here. This disk structure that's formed, this accretion disk, ends up becoming the disk of the galaxy over time. That's one of the thoughts they have for how galaxies actually form. And then the spiral structure, as I said, through a disturbance or a perturbation, you can get a burst of star formation, which then gets drawn out by the differential rotation to make the spiral arm. See, we're reviewing it all. And then the density wave could also be sparked by another nearby object that actually causes a ripple that ends up getting transmitted through the galaxy which ends up, because of the motions of the stars and their angular momentum moving around the center of its galaxy, can cause a spiral pattern to break out. And the spiral pattern seems to be a very common outcome. All right. So in 1926, there was someone who noticed that and said, why are these galaxies looking this way? And that guy was Edwin Hubble. Now, Edwin Hubble, famous American astronomer. Here he is. Okay. And Edwin Hubble was just unrelenting in trying to figure out how galaxies are arranged in space and their morphology. Do they go from one type to the other? How is it that galaxies form? And what he ended up coming up with was something called the Hubble tuning fork diagram. And this is after classifying and looking at many, many galaxy images that he had taken in the large observatories. And this is Hubble's classification mechanism. We have two different basic kinds of galaxies. Okay, we have elliptical galaxies and we have spiral galaxies. Among the spiral galaxies, we have spiral galaxies with arms. Those are the ones across the top row to the right. And we have spiral galaxies with a round central nucleus, like those along the top right. And then we have galaxies with an extended nucleus, like those around the bottom. And that extended nucleus is what was termed a bar, like a bar of stars moving from one side to the other. And that bar is actually what actually caused the spiral arms to form. When they formed in certain ways, they would form differently than a regular spiral galaxy. And that's kind of what Hubble did. Now, de Vaucouleurs came along later, and he took that tuning fork diagram and he refined it. So we have E0 is in the Hubble classification to E7 for elliptical galaxies, which you see outlined as ellipticals there. And as you can see, it's the more and more stretched out galaxies. Then we have what are known as lenticular galaxies, which are spirals, but very spherical with very, very tight spiral arms. And like in the Vaucouleurs nomenclature, they're S0A, all right? And then if there's a slight elongation to them as below in the lenticulars, it's an S0B for barred spiral. However, Vaucouleurs also had this additional tuning fork segment, more like a pitchfork, that goes straight out to the right. And so that was for galaxies that weren't quite spirals like those across the top and weren't quite barred spirals like those across the bottom. And guess what? We see a lot of that out in the universe. So de Vaucouleurs' diagram is very important because it shows a way to give a name and nomenclature to these different galaxies. So you could be forgiven for saying, well, that's an SABC galaxy. Huh? What? SA is a spiral galaxy. The capital B means that it's a barred spiral in addition. And the C means that the arms are loosely wound. Now, we actually have examples of this, and I think I would be able to show you those. I do have to ask Amanda, when's our break, Amanda?
In about 2.5 minutes.
2.5?
Yeah.
Oh, goody. So that might work for us. I'm going to actually, I'm going to bring us back into Photoshop here. Daryl, did you want to add anything? Because when we come back, I want to jump into the deep dive with you.
I don't remember if I've ever noticed, but Hubble was a homeboy.
Wow.
He was born and raised in a small town just northeast of where my hometown is.
Wow.
And
Wow.
he got out as soon as he could, believe me. Little town down the Ozarks. I forget, Marshfield, I think, or
Holy cow.
Marshfield, Greenfield. I think it was Marshfield.
You guys all know what a wealth of information Daryl is. And if he can still be learning something new every day, then there's no excuse for anyone out there. So again, I'm glad everyone joined the show. Hopefully you take something from it like that.
And I think they will.
I know they will. I always do every episode. So
yeah,
never stop learning.
Me too. Yep.
Yeah.
Oh, yeah. There's never with this topic. There's never going to be an end of questions until we have absolute proof either way. So
that's right.
You want to back up some. I missed a little bit of what you were saying about Hubble, but a guy named, was it Earl Rosser or Lord Rosser? He built himself a great big telescope. Yeah. Okay. He built himself a great big telescope, and he was a guy who discovered spiral structure in galaxies.
Yep.
Specifically with M51 Whirlpool. He didn't realize what they were. They used to just call them spiral nebulas because they thought maybe that's where stars were forming. And it was Hubble who figured out the true nature of galaxies with the Cepheid variables, which is probably what you talked about while I had to step away.
That's okay. Yeah, I didn't mention the Cepheids at this point, but that's okay because I want to point out when we were talking about Valkeler's diagram here, see these barred spirals down along the bottom row here? All right. Now, you have to say, well, how do those look in actual reality? Well, here's a pair of them, right? This we took just the other night. These are, this is Messier 95, and this is Messier 96 over here.
Yep.
And when you look at this galaxy up close, right, notice that it has this prominent bar right across the middle. There's a bright nucleus, but then you have a bar of stars. It almost looks like a TIE fighter coming right at you, like Vader's TIE fighter. Okay,
it does.
Right? Doesn't it? Like I have you now.
Steering wheel.
That's right, or a steering wheel. Yeah, that's because it's face on to us. If it was on an angle, then it might look a little bit different. It might look somewhat like, say, this guy over here. This one is another barred spiral, and it's sort of on an angle to us. But if you look at it, okay, you can see that this is just a gorgeous galaxy in and of its own right, you know.
I think it's break time.
It is.
All right. Well, when we come back, we'll talk more about this. And cool. Hey, you know, maybe someday we'll go completely commercial free.
Yeah, but in the meantime, gather your questions. We are watching chat, so if you want to know, here's a good place to find out.
There you go. All right, guys. Well, we'll see you in just a few minutes. Stay tuned.
Hey members, the new KGRA DB app is now available on iOS and Android devices. Gain on-demand access to any KGRA DB programming. Download any show directly to your mobile device to listen or watch on the go. Go to the App Store and search KGRA DB.
Scrolling all day, time can disappear. Wanna make it count? Why not volunteer?
Posting pics of your food, that takes up time. Time, you've got time to binge all of season 9, though it got so bad.
Time, you got time. We're gonna grow back and be the same browse you had.
Just a few hours to keep families from harm. Help us end home fires, but sound the alarm.
Volunteer for a day to install free smoke alarms in your community.
Discover the Observation Deck, a one-of-a-kind virtual event platform that takes video conferencing to the next level by using avatars to navigate a campus. There's so many areas and activities to choose from. There's a 1,000-seat auditorium, an expo hall, a nightclub, and even a beach. So come attend a conference, take a class, or hear a lecture on the incredible Observation Deck campus. Go to theobservationdk.com.
You're listening to the KGRA Digital Broadcasting Network. We provide unparalleled coverage of trending news in the world of ufology, cryptozoology, and paranormal phenomenon. Whether you're watching our video live stream or listening to one of our audio programs, you are getting the best from world-renowned researchers and hosts, guiding you through topics the mainstream won't touch. Miss one of your favorite programs? No problem. Head over to the members area at kgradb.com for access to our massive library of award-winning content, Make contact, stay connected. Only at KGRADB.com.
Hey, welcome back to SkyTour Radio. This is Mark and Amanda, and a little further over is Tara, and then all the way at the end is Daryl. But I just want to just let you know, as I talked about before, this is an example we talked about with our barred spirals. This is a barred spiral. You can see that bar going right across the middle. That's what we call a barred spiral. And if we talk about just regular stars that are, I'm sorry, regular galaxies that have, like the Andromeda Galaxy, that's this guy. This is a spiral galaxy, an ordinary spiral galaxy. You see spiral arms. Nothing incredible about this. There's no bar really in this. All right. And then we look at Messier 33. This is the Triangulum Galaxy. This is messy. All right. This guy here, the arms are a little tighter. This is a galaxy known as a capital S, capital A, B, meaning it's a less tightly wound than an A, right? But Messier 33 is a C. It's actually got more loose, messy arms like this, and a lot more going on. So this is kind of what we see with with this galactic classification. So between Hubble and the Vauquelin system, Day Vauquelin, we actually get a full classification of galaxies to give us a chance to understand what's actually happening. I think with that, what I'd like to do, Daryl, is have you go through the evening sky for us tonight. And
okay.
As you hit a few things that you might think we need some pictures for, we'll just pull them up.
Very good. I may show a picture first. I don't know if this is going to work or not, but somebody joked about, let's see.
Wearing shorts?
Yeah, I don't know if I get that up online or not.
Oh, that was a while ago. I'll look for it. Yeah, you guys were talking about meeting in Denver and that you'd just be in shorts and a t-shirt, and someone must have imagined hot pants or...
Yeah, there's an old picture of me wearing short shorts, and
Daryl, what are you doing to me?
I don't offhand see that. So, yeah, I'll just go ahead and do the deep dive thing.
All right, Daryl.
If you have that picture and you want us to show it, toss it in.
We'll see.
Someone may be getting their wish tonight.
Okay, here we go.
All right.
Okay, is Stellarium up on screen now?
It is indeed.
Very good. Now, I'm doing something a little different tonight. I usually start in the west at sunset, but this is showing the morning sky facing due south. I have atmosphere turned off, so I'm going to back up to 5 a.m. Tara asked sometime back, it was sort of in the context of Venus and Mercury not wandering very far from the sun in the sky. And she mentioned planetary alignments. And we haven't been here for a while, but I wanted people to see this. And if you get the chance and you can get up early before sunrise, you can see this right now. Almost all the bright planets are doing an alignment in the morning sky before sunrise. They're west of the sun. There has been a very interesting series of conjunctions and close passes rising happening, which I won't show all of them, but Saturn here farthest out. Saturn was in conjunction with Mars, and a while back Venus was in conjunction when Saturn hadn't moved so far out. And right now, 4 of the 5 planets that the ancients knew by sight, the wanderers, are up and obvious in the morning sky. Jupiter is closest to the sun, then Venus, which is very bright, and then Mars, and then Saturn. I'll go ahead and give you the stick figures. There's the teapot in Sagittarius. There's the scorpion, the tail of the scorpion. And right here is the center of the Milky Way. And then going on over toward the east, well, you've got Saturn, Mars, Venus, and Jupiter arrayed in the morning sky. And in the coming days, we're going to see, you see Venus and Jupiter are moving closest together, closest, to where they're going to be the closest conjunction that's going to happen in quite a while. Venus and Jupiter are almost going to be touching. So that's something to watch for in the coming days. It will be a beautiful sight. So here we are back to we're the 24th today. I just wanted to tell people that. And then in June, okay, you see Venus will have passed Jupiter. Mars will then be coming into conjunction with Jupiter. And Jupiter and Saturn moving, that's because of the Earth's rotation around the sun and stars moving west day by day and the outer planets moving along with them. But then over here, close to the sun, we'll go one more month. Well, here Mercury has come up to join them. And it's going to be a beautiful sight that you will see all the naked eye planets arrayed across the sky in June. Plus, over the course of several days, you'll see the moon is going to join each and every one of them. There's Saturn right there on the 18th of June. On the 21st, it'll be by Jupiter. On the 22nd, it'll be by Mars. A few more days, it'll be by Venus and then Mercury. But the moon's getting really skinny by then. But it's going to be a beautiful sight. And go out now to C4. And if you can make it in June before sunrise, you'll be able to see all 5 of them arrayed across the sky. So now we're going to go back to the usual in the west after sunset. And I'm going to give it a couple hours so the sun goes away. Right now, Mercury is in the evening sky, so it's low over in the west after sunset. You may or may not be able to see it. But I just wanted to convey here that the stars of winter are indeed going away. Orion is setting by 9 or a little after right now. This is my sky. And here's a little after 9 o'clock at night, and Rigel's about to set already. And all the stars of winter are going away. And what we've talked about in the past is what's known as the winter circle. All the stars in the western half of the winter circle are setting. So all there's going to be left to see is Procyon, Pollux, Castor, and Capella on the east side of the winter circle, and that's called the Arch of Spring. And we'll back up again a little bit. Mark, whatever you want to jump in here, did you want to show the things we talked about that are here just on the east of Orion toward Monteceros?
Sure.
Okay,
sure.
Well, jump in. I know you have an object or 3.
No, it's okay. But, just to show folks what's hiding in that region, before Daryl continues with the view.
Right in this area.
Yeah, we actually have this amazing object here. This is actually known as the Boogeyman Nebula, otherwise known as LDN for Lund's Dark Nebula Catalog number 16.
Where was he for our past Halloween episodes? This is exactly the kind of thing I was looking for Halloween.
Yeah, but you don't really see the boogeyman, right? I mean, it's sort of,
Is his head going to the right?
Yes, he's sort of laying on his back.
Yes. Right okay.
He's laying on his back.
Cartoony Cyclops.
He's spooky.
Yeah, Amanda, we I had been doing some looking for things to see, and I came across this one. I suggested it to Mark, and we went and found it on the east side of Orion.
Wow. Thank you. That, I mean, I don't know if you subconsciously did it for me or not, but this is the kind of thing, like, of all the streams we've done in all the years you've been on YouTube and KGRA, I can't believe this is the first time I'm seeing it. He looks like a cartoon. This one I see, I don't know if I'm seeing the right thing, but I see something, and maybe it's an after image, like if we all stare at it without blinking for 30 seconds and then look at a white wall, then we see the monster. Like, I hope I'm not giving people nightmares, but yeah, like you stare at a black image, and when you look at a white, it's all in color. It's like red and green. Yeah.
He's facing down now. Mark rotated the image. Yeah. Could you go clockwise 90 degrees, Mark?
Like a minion.
Minion, yes. I'm like, well, maybe with that. Yeah, let me.
I just see the dark shadow.
Yeah. There is the boogeyman. The lump at the top, it's like he's wearing a hood.
Well, this.
Some ways, like in this view, he's almost like the Grim Reaper. But he's wearing a hood, and his arm is out to the left and to the right. And he's the boogeyman.
Is this the arm in that view?
That's one arm, and the other arm is over right there on the right.
And then there's his legs
coming
down.
Oh, okay. So this is the head with a hood on.
Yep. And this is over on the east side of Orion, just a little bit north of the Casper, the Friendly Ghost Nebula.
Which is to the left of Orion, for those wondering. When you look at Orion, it's to the left. In the northern hemisphere.
Yep.
Is this... Does... Okay, I don't know if this is even going to make sense, but you guys know me. You can make sense out of it. Does Libra pass through this area in October?
No.
Libra's Libra. It stays where it is in the sky.
Or the other way
Libra
around.
moves with the seasons, but Libra never gets any closer to Orion. I mean, they're fixed stars and constellations.
Okay. So I thought, like, when the planets go through the constellations, like, I was thinking, again, with the three-dimensional space, I really get lost easily. So, but you know what I'm going for, right? Like, Libra and October and Halloween. I thought with the zodiacal kind of.
Oh, I see what you mean.
Yeah.
It would October, feature this guy.
Yes, would it go through Casper the Friendly Ghost and the Boogeyman and like the Witch Head or the Broom or?
You would have to look early in the morning, but you would be able to see this in Halloween.
That's
about
cool.
3 or 4 o'clock in the morning.
That's the Boogeyman comes out about 3 or 4, the witching hour around Halloween. There is your mythology. I love that.
It. Yeah.
Oh, right. Thank you, Daryl. This is the highlight of my night. The Boogeyman.
Pity you weren't there when we found it.
That's cool. I guess, remember him for October, guys. When I forget, remind me we have a Boogeyman.
Well, you will. I'll remind you. And then let's see. Right next to it, sort of near it.
Yeah, the Boogeyman is just to the upper left of Alnitak, the leftmost star in the belt of Orion.
Right.
Ooh.
And then right there, this is the Casper the Friendly Ghost Nebula.
Which is just below the Boogeyman.
Yeah. Looks like a Metallica album cover. Yeah, that's true.
Getting back to, I got so taken with the Boogeyman. I'm just.
That's okay. The Boogeyman's beautiful.
Seeing a lot of it artistic. Yeah, see, and that's what I love. When we didn't have the science, we had the philosophers, and we had our best guesses, and we had,
Yep.
Like Zeus must be mad at us. Why else would there be thunder and lightning? It's our fault. Like, well, I mean, hey, it was the best you had. And
well, yeah, I mean, there was no science to make a counterpoint to the cultural positions. It's true.
Yeah, a lot.
And that's why astronomy had such a hard time being acceptable science. It was astrology for the longest time.
Yeah.
Astrologers and astronomers used to be the same thing.
That's right. And
I mean, we don't have proof anywhere. Like, we have great theories, and we're getting bits and pieces of things, but we're trying our best to explain things we don't know either, right? We're just a little bit more advanced from back then.
I wouldn't agree that we don't have any proof of anything. I mean, we actually have theories that end up being backed up by countless experimentation results that show that it's exactly what we see. So, I'll give you an example. When we talked about Messier 87, the galaxy in Virgo, which has this supermassive black hole, that was the subject of the telescope that was used using the whole diameter of the Earth, okay, to actually capture the shape of the black hole and look at the black hole. But theoretical calculations to show what it looked like and what it might look like were actually exactly right, 100% right. And so we saw this exact object as expected, all right, with this telescope, the Event Horizon telescope that spanned the entire globe. So that's so science is proven right many times. So
no, well, that of course, and that's why it's science and not mythology. But I'm sure it was in my lifetime that people still believe the atom was the smallest thing in the world.
Yeah.
Until we split it open. So I mean, one little discovery can change an awful lot that we assumed we knew for a fact.
True. That's true.
So, but that's what makes it exciting, right? Welcome to life. Yeah.
That's exactly right. That's exactly why we see things like this and then things like this. Now, keep in mind that objects like this were the realm of large telescopes only in the past. All right. And, lucky for us, we actually have the ability to view objects like this now because of advances in telescope capability. I mean, look at this beautiful shot.
Yeah.
It used to look like smudges, didn't it? The very
Yeah.
first pictures.
Yeah. Dark nebulas and stuff like this is something that we pursued, particularly since Mark got his telescope dialed in, collimated, working at F2 for the Hyperstar system. And we found that we were having great luck finding dark nebulas and stuff like that.
That's right.
So we looked at a ton of them.
Yeah, and we still do.
Stuff like the Iris Nebula and
yeah, that's right.
All that stuff in the summer sky all the way to here in the winter sky.
That's right. And we still look at all that stuff,
Yep.
And we're going to continue. In fact, we're going to be spending a lot of time as the summer rolls around. We're going to be looking at a lot more beautiful objects. Okay, like the Iris is this. I mean, look at this beautiful object.
Wow.
That's gorgeous too.
Oh my goodness.
Now, from here in Connecticut, I was only able to image this part of it with just a little bit of the outside. But in Arizona, look at this. You can actually see a three-dimensional separation between the background stars and this dark brown silicate-based and carbon-based cloud of dust that's lingering out in space. Again, littering the galaxy. Just like with the other spiral galaxies we see with their spiral arms, it's in those spiral arms where this gas is and dust is collected predominantly. And it's the location where stars and planets form. A star formed here. And the star doesn't have any hydrogen gas to excite in here, but it does have these dust grains. And these dust grains, it actually illuminates with its starlight, and the dust grains turn around and scatter the blue light in all directions. You'll notice that this blue is the same color as our blue sky. It's because the scattering or the process done to show you this blue is the exact same process that's used in our sky as well. The wavelength of the dust grain is just about that of the blue light. And so therefore, in our atmosphere, it's the same process, and the molecules in our atmosphere of both dust and oxygen and nitrogen are actually around the same type of size. The dust grains are about the same type of size, and so they scatter the blue light equally well. So it's pretty cool. I mean, this is one of my favorite Iris images, Daryl, because we actually see the separation between this material and the dark of space. Because when you look at this with a telescope, you see the dark of space, and it's dark of space everywhere else you look, except when you take an exposure that's this long.
Yeah.
You can see areas that are denser too, which is really kind of cool. Anyway, so Daryl, let's go back to your beautiful stellarium work for tonight, and we'll pick it up if we have anything else to say.
Okay. Well, this show's supposedly about galaxies. Let's do some galaxies. Now, folks, as we were saying, Casper the Friendly Ghost is right about here, and the Boogeyman Nebula is right above it, right about here, just to the left of Orion. And we're going to march on over toward Leo now, and Virgo, and Coma Berenices, and Arcturus, and we're going to go on up toward Canis Venatici and Ursa Major, because now it's that galaxy time of year. And as I said earlier, and kind of a band across the sky from Ursa Major down through the hunting dogs, Canis Venatici and Coma Berenices, to Virgo and Leo, and even farther south, down here toward the south, it's galaxy season. There's 1,000 brightest galaxies in the sky. 3/4 of them are in a band right in this part of the sky.
Mm-hmm.
And we have been checking them out lately. So where would you like to start first, Mark? You did M95 and 96.
How about the whale?
Oh, the whale?
Yeah.
Okay, Canis Venatici then. I will turn on the art here so you can see. Canis Venatici, these are called the hunting dogs. And this is where M51 is, the whirlpool, and also the whale, if I remember correctly. Am I right?
Yeah, I believe it's up in that area.
Okay, I'll hand it over to you.
All right. Well, basically, in that region, we start by looking at a great swath of space, and we notice there's some galaxies. I mean, as we got our telescopes became better and better, we started to identify these spiral nebulae. And I have this book right here, which I think is a great book. It's falling apart, but the book is actually called Architecture of the Heavens in a Series of Letters to a Lady. And it's a beautiful book written in the 1800s, and it discusses spiral nebulae. All right. And these spiral nebulae are things that are just the most amazing. If we consider that all they could see was this rough shape of these nebulae and didn't know what they were. But we actually know that what we're looking at, in fact, is this amazing group of galaxies. And we now know that they're island universes, clusters of stars, all rotating around a common point, a central point. And that's what these galaxies are. Now, in the Canis Venatici sky, we have this galaxy. Now, this galaxy is called the whale. And I'm going to ask Amanda if you can see the whale, Amanda.
I see a fish-like thing. If it was, to me, when I think of a whale, I would see it would be a lot bigger. It would be a lot rounder. That looks like, oh my God, what are they called? Like a manta ray. The really flat ones.
Some people call it the herring.
Okay, yeah. Yeah, I see a fish. Like, I see, like, sharp edges, like maybe like a shark fish or something, or like a, what are they called? Are they shark fish? I can't remember. Or like a manta ray where like there's kind of like the triangle part at the top and then it's smooth and flat. But a whale, I would think, would be rounder at the top and bottom, and maybe there would be like a little puff of water over top, like a exploded stars on that's why I don't see them. They have to be really obvious, really cartoony, or draw an outline for us. Can you?
Okay.
You don't have a pen here. You can like one of those visual pens where you can outline it.
Only in the live stream, not here.
Okay.
But I can say this: if you consider this the head, this could be the pectoral fin, that big fin, and then this is the rest of the body with the tail flukes back here. Okay. This looks like a humpback whale from the side, believe it or not. It's not. The humpback's not as big and round as you might think. It actually kind of looks like this. That's a really good profile image for that. But you're right. It looks like a herring. It looks like a sturgeon. It looks like a shark. It looks like
who
any number of
needed a
fishes.
degree in marine biology to watch a astronomy program.
Yeah, right. That's the whole point. Yeah.
But
I
if
love
you look
the
at that,
zoology in the show. Yeah.
if you look at that, part of what gives it the shape, the deformity.
Yes.
That deformity is a gravitational interaction with another galaxy.
That I'm about to show them right down here, but not there. I'm not there yet.
Not the other one seeing things.
Okay.
Yeah,
All right, but see,
squid,
It does look like a squid.
dog
oh
dick
yes, it does. If this is the
ball.
head of the squid, there is the eye, and this is like the cephalon area, and then there's the tentacles. I mean, yes, it could be the squid. It's even got the right color in some ways.
A lot
Okay.
of people are saying squid lake. I want to know, hold on here before we
Okay.
go.
Yeah, no
What
problem.
we have a flatworm galaxy?
Planaria, the flatworm. Yeah, it looks like a planaria. Charles, if it's a planaria, it needs to have this the other thing on the other side to be a planaria. That's a microscopic.
We have
Would we cut it in half?
we have one of the smartest chats
We always
in
do.
all of YouTube history. They are just on fire. They don't miss a trick, eh?
And they're chatting up a story. And we had 250 chat messages. Now we're they clear once I go in. So some of you see a larger number. But
We have several streams, several
Right.
channels carrying the visual component, and I see it all. I just can't find them to acknowledge them all in the real chat. So, hi
That's
everybody!
okay.
Thank you for being with us. Thank you for your support.
No, we love
Keep
these
the
people.
comments coming.
Yeah. Notice, okay, at this end, okay, of the whale, all right, if we look right in here, you'll notice there's something else going on here. We see this greenish object. Now, and first of all, when Daryl mentions the deformity in the whale actually is in the form of the shape. If you notice the shape, okay, it has a strange taper here. I mean, there's this long taper here, but it also has, if we back out a little more, right, and if I actually kind of just monkey with some settings here, just to give you a little idea, you'll notice that there's some additional stuff out here, all right, and some additional stuff here. And by the way, Daryl, yesterday we were talking about this object right here sticking down from the ham. No, that's not here. That was in the hamburger. We'll get to that when we get to the Leo triplet. Anyway, again, from the point of view of this being a whale, okay, we see there's more stuff. So this galaxy has definitely been disturbed by something, and the question is, what would it have been disturbed by? Now, again, these stars you see here, these are all in our galaxy. They're all up here. If you look at my hand down here, and this galaxy is like millions of light years way out here. Okay, so we're seeing foreground stars. Every one of those dots is a foreground star up here and close and personal with us, right? So now, if we move down, you'll see another galaxy that is really grossly misshapen. Now, this is a satellite trail. This is a Starlink satellite that went zipping through. The red dots and the green dots, these are just artifacts of the camera that we use out there. But check this out. This is a really interesting galaxy in and of itself. It has some green objects as well that we'll talk about shortly, several more. But look at this curve. Remember I told you about Messier 51, that Whirlpool galaxy, and I said how it looks, when you look at the Whirlpool galaxy, it's face on to us, so we can't see that the small galaxy at the other end is doing anything, but we turn to its side, it's going to be like this. It's going to look like that. It's going to actually be tipped downward, as you can see, right? And then from the top, it looks like this, but from the side, it's like that. Well, we're seeing this galaxy from the side. It had been tugged in a particular direction. And you might say, well, wait a minute, this galaxy's up here. So how could it do that? Well, it did it probably in one of the other iterations. These galaxies are all slowly orbiting each other, and maybe they came close and this one moved away. And this is the snapshot in time we got right now.
Yeah, and that was something I wanted to mention. Just like the processes that we saw in M51 Whirlpool and its satellite galaxy, these are the same things that are deforming these galaxies.
Exactly. It's the gravitational tugging.
Yeah, and where we were seeing M51 face on, this could sort of maybe show what we might see if we were looking at it sideways.
So that's not two galaxies, the one on the bottom left?
Yes, it is. Oh no,
Okay,
this is one
that's just
galaxy.
one. Okay.
Yeah, and this is one here, and these two are actually gravitationally interacting. See, human lifespan is so short that we don't live millions of years. If we did, we would notice over our lifespan that this galaxy and this galaxy change position relative to each other a little bit over time. We'd see them maybe a little moving, a little different. One's a little awkward off from the other one. We might see them get closer. We might see that arm here change its position. It might start tugging back up. It might be doing this, but we can't see it because it takes too long to actually watch it do that, because we don't live long enough to see it.
Yep. And they're millions of light years away, so we are in no position to move over to get a sideways view.
That's correct.
Yeah.
However, looking at this galaxy, you'll notice there's another one up here. This is actually a satellite galaxy to this one, and this one is one of those Hubble types that begin with an E, an elliptical, and the Valkylar's setting, I'm not sure what it was, probably like an E6 or an E7, meaning it's pretty stretched. I'm not sure what the classification is for this.
Yeah.
And as far as this galaxy, we see galaxies that don't have any real shape at all. And those are called irregular galaxies. Go figure, right? And who knows? They could have been galaxies like this that maybe got torn apart. Maybe they were galaxies that were never normal and were just starting to find a structure that ended up not fleshing out because of gravitational disturbances by other nearby galaxies. So there's a lot of cool things in there. But that's the first one we wanted to talk about. And the other one is well, where should we go next year? Let me think about that, because
Ursa Major or Coma Berenices.
Yeah, if we go to Coma Berenices, then I want to take us back to the Leo triplet, but I want the Black Eye Galaxy. M101, actually, Escher 101.
M101, that's the pinwheel.
Yes, it is.
Very good. Do you want to show it in the stellarium?
Yeah, why don't you do that? So let's bring that back up. Why don't you?
Pinwheel kind of coincides with spirals. We have the whole. Are you trying to hypnotize our viewers?
We are.
He's going around.
We're taking down our
personal
path.
Do you see stellarium now?
Yeah.
Okay, we're going to go to M101 Pinwheel Galaxy next, and that is right about where the tip of my pointer is. If you see the Big Dipper there, here is the handle. Alkaid is the end of the handle, and this is Mizar, actually Mizar and Alcor. And M101 makes pretty much a equilateral triangle right here with Alkaid and Mizar. And take it away, Mark.
Okay, if we look in that location, what we're going to find is this galaxy. This is the Pinwheel Galaxy, Messier 101, and it's a spiral. As you can see the spiral arms. But, you have to look at this and you say, well, how did this particular galaxy get its spiral arms? And that is always a good question, but there's something that has been perplexing to astronomers and so forth. And that particular Perplexicus giganticus is the fact that this arm has this strange bend in it. And we're not sure why this arm has a bend in it.
Yeah, and the next arm in has a similar bend in it.
Yeah, right here. You're saying this arm here.
Yeah, right there. There's a crook in that arm also.
Yeah. So what could have caused that? And it could have been the same process that actually caused these galactic spiral arms to form. This is not one of those barred spirals like we talked about. If you remember, again, bringing up that Hubble tuning fork diagram really quickly, or I'm sorry, De Valkylar's, right? This spiral is one of the ones up on the top going across to the right.
Yeah. If Hubble had a tuning fork, leave it to a French guy that looks more like a salad fork to me.
Looks like a pitchfork to me.
Yeah.
But yeah, so in this particular case, again, one thing to notice is that you see some beautiful blue stars in the disk here. And those blue stars correspond to young stars, hot stars that formed in here. And along the edge here, you can see a brilliant set of blue stars. These are probably what are called OB associations, O and B type stars that are very, very hot and young, don't last a long time, go supernova quickly, and just after a few million years. And the green here, these might be areas that are supernova remnants already in this galaxy.
Two big ones there to the left of the nucleus.
Exactly right. That's right. Right here.
Yeah, one right there, and then another one farther out, and another one above that.
Yeah, there's this one here. That's most likely a supernova remnant, and this is most likely a supernova remnant. This might be blue, and I just have to. These might be blue, actually, not green.
Yeah, I looked at the Hubble image of this the other night, and that one just above your pointer, I think that is a large OB association also.
I do think that that's a association of these very hot young stars. Green and blue can border together, and you have to be really careful about how you color correct. And so I color corrected properly. You see that the stars are actually yellowish orange in the center of a galaxy, and the disk stars tend to be the younger ones. Notice all the dust. Look at all this dust in here. This intergalactic dust is just incredible. And so again, this is a spiral galaxy that has an oddity to it. So we would probably classify this with some type of peculiar rating of some kind. Now, for those eagle eyes, you're also noticing this one out here. That's another galaxy that's farther out there, but I'm not sure of the distance of this galaxy versus this galaxy. But if this galaxy is at the same relative distance, then this one might be the reason for the crook in this arm.
Exactly.
People in chat were asking about that. What could have caused that?
Oh, I figured there's some people that are smart out there.
Yeah, it could be a satellite galaxy of M101, and I've wondered that myself, if that could have caused the distortion.
Yep. I wondered.
Speaking of chat, we have a question here from OG Skywatch.
Okay.
Don't they all have a large black hole in the middle?
Yeah, it's those are the SMBHs, the supermassive black holes, and the theory is that most galaxies have a supermassive black hole in the center. Ours does, M87 does, and ours is a barred spiral galaxy, and M87 is an elliptical galaxy, but round, so it's an E0 type galaxy where it's actually really almost spherical. All right. So it seems that it doesn't matter what type of galaxy you are, you can have a supermassive black hole in the middle. And maybe that forms, and this is a chicken or the egg situation. We don't know whether black holes, that's funny. Yuffie says, so are galaxies or black holes the human navel of galaxies? I hope not. It could be a different part, but let's be careful.
We're PG-13 here.
Yes.
Yeah. Well, this gets into cosmology almost, where we were talking about, what caused the galaxies to form early on. And some say that early black holes formed after the Big Bang helped create the galaxies that we see.
And it wouldn't have to be a very large black hole to begin with, because black holes can grow. And the black hole, for instance, around or in Measure 87, which is 44 million light years away, we're seeing it as it was, tens of millions of years ago. But that particular black hole might have been a lot smaller to begin with. But as stars orbit and as they start to lose mass, and some of that mass and gas might have been absorbed by the black hole, over time it may have grown. Contrary to what you might think, if an orbit has been established, then the black hole will just sit there and won't grow any bigger. In fact, it'll start to evaporate. I'll give you an example. Our sun. If our sun turned into a black, it can't, but if our sun turned into a black hole through some magic, then the planets would continue to orbit around the sun, and that'd be the end of it. Nothing would happen. If the sun, with its current mass, turned into a black hole today, it would just be dark. But stars that are around 2.5 times the mass of the sun on up to 30 or 40 times the mass of the sun can become black holes under certain conditions. The higher ones will almost always become black holes. But the fact being, black holes don't just suck everything in around them. If it's orbiting in a stable orbit, then it just continues to go along like it always has. So you could have, for instance, a black hole orbiting a neutron star. And as long as they're orbiting at a reasonable distance, they'll just continue to happen, go on and on and on forever and ever until the black hole either evaporates or the neutron star, alters for some reason. But the bottom line is that when we talk about a black hole growing, it's because of unstable orbits. And when the galaxies are first forming, we talked about them being clumps of stars with very chaotic orbits in their center before it settles down into a disk. So initially, those stars might end up passing close to this foundational black hole if it was in the middle of the galaxy and form a fairly large gravitational center. Then it makes it easier for a galaxy to form, as I think Daryl was mentioning earlier.
And sometimes, though, take our Milky Way central black hole, Sagittarius A star. There are videos, animations on YouTube of the neighborhood directly around Sagittarius A star. And it's like bees swarming around a flower. These stars are in tons of orbits. Some are really tight, some are pretty loose, but they're buzzing around the black hole. Sometimes they pass too close, and sometimes they get ripped apart, and they become part of the accretion disk that's feeding the black hole.
Well,
that happened just fairly recently. In fact, a large star in a gas cloud went by, and the black hole ripped it to pieces.
Wow. Yep. Well, I was going to say I felt better when, like, Mark always says, like, if our sun, for some magic reason, turned into a black hole, nothing would really change because we're established. I felt better because I saw this comment here, in essence, stars spinning down the drain. But there might be some truth in that when the galaxy was first being formed. If it was unstable, maybe that's a good analogy for what happened. Is that accurate, do you think, or still a little off the mark? Because they aren't really going into the black hole, right? They're getting ripped apart before they get there.
In a sense, okay, if you think about how black holes operate, they're going to be stretched and elongated, and they might continue to orbit, all right, a couple times. But then as more mass goes into the black hole, what happens? The black hole actually grows in size, making it harder and harder for the star to maintain itself as it goes around the black hole, and eventually it's definitely going to end up losing the battle.
How does a black hole evaporate?
Well, see, what happens at the surface of a black hole, all right, the event horizon, there's a lot of processes going on. A lot of energy is being lost, a lot of magnetic forces, electrical forces, and so you can't just spew out this energy from nowhere and expect it not to cause a drain on something else. So over time, those black holes are going to be giving out more and more of their own energy until they evaporate. However, keep in mind, it's going to take many billions of years for large black holes, if they ever evaporate. Let's take a look. Yeah.
Small black holes could have already evaporated, probably have.
That's probably true.
One of our questions was how small can a black hole be, I guess, before it evaporates or can still be considered a black hole? Is there a magic number?
Well, you keep in mind that black holes, some black holes, you could have microscopic black holes, and they're not formed in the same normal way that, say, a stellar black hole is formed, but they're in the quantum mechanics realm. But if you look at regular stars, we're talking about like stars like this here. Okay, what is this? You'll ask. I'll show you in a sec. But you can see it right now on the top title there. When you look at a stellar black hole, we're talking about something that it's going to be several times the mass of the sun. Like the largest neutron star again, it's just the core we're talking about. After the star does its explosive processes or whatever and blows up, if what's left over is more than around 2.4 to 2.5 times the mass of the sun, then it could become a neutron star that will continue to collapse into a black hole. And when it does that, you can be sure that this will happen. Here is that footage. Those dots. This is not water. Those are stars orbiting around the central black hole, Sagittarius A. You see that star there? It gets whipped around. Like, watch, ready? Whip. Right? It does it one more time. Whip. Whip. Okay, this is an example of what we're talking about when we're talking about black holes that are in the middle of a galaxy. A supermassive black hole's in the middle of ours, and it's causing the stars near the center to do that. Well, imagine that star that's whipping around that center. Well, as the black hole grows in size and accretes more material, it's going to grow in size. Its Schwarzschild radius, as we call it, is going to grow larger as it accretes more mass. And therefore, that's going to make it less possible for the stars to survive. So it will eventually eat stars.
That looked like pond water under a microscope.
It does, doesn't it?
It's so, the similarities are so eerie to some of the things under the water. And then, I mean, I'm not saying it's aliens or anything like that, but it's got to be hard. Like, and I'm not talking about like sophisticated telepathic space traveling, but I mean, even things like this, like amoebas is life. It's hard to believe that nothing else exists besides us, and the similarities, we don't know like a fraction of the stuff in our own oceans and seas. So
it looks alive.
Space,
It does look alive, Sarah.
It does.
Now this is a 20-year time lapse, by the way.
Maybe it is alive.
Yeah, well, Gaia.
What's alive?
Yeah, exactly. Okay, but
we only have 10 minutes left, but who wants to take that one? What is life? 10 minutes?
No. I just want to say,
magazine.
You see this star that's getting whipped around here rapidly, right? This star, whim, that guy getting shot around there. I can tell you that I'm guessing that tidal forces caused by the close proximity to Sagittarius A if there were planets around this star, they were stripped away long ago, because the tidal forces are immense as the star gets near Sagittarius A, and we don't even know how close it gets. But over a 20-year time frame, those forces are pretty intense when it gets really near the center like that. So just wanted to mention that. Now, I did want to give Tara some time to ask some questions, because we have, I was hoping I'd get to her by 1:15, and so I'm sorry it's a little bit late, Tara. But I'd love to hear some of your questions that you have, because, again, we're in this beautiful galaxy of ours. There it is. Okay, that's M101 still. But we'll be coming back to all these things in another episode as well. But let me hear from you. What do you got to tell me?
Well, this has been totally interesting for me. Okay, well, for something completely different, I got a chance to get out of state recently, and I was in Hawaii with I know, and with my friend Marianne, but we looked up and the moon was upside down. And we got really confused about that. And I mean, had we changed the latitude enough that the moons had attitude had changed? Because
no.
Well, you were right about on the Tropic of Cancer.
Yeah.
I mean, Hawaii
They're
is
around 19.
Yeah, Hawaii is inside the tropics. The angle will change with your latitude. It can look strikingly different from different parts of the world. If you were, you're farther south to the tropics, you're about twice as close to the equator as you were from where you live or where I live. Mm-hmm. If you go down to the equator, it's going to look much different. If you go down in the southern hemisphere, it's going to look very different. The orientation is going to change.
It'll truly be upside down below the equator. But when you get close to the equator, the angle is such that you might have thought it was upside down.
It switched like from this way to that way. It kind of switched the way the half moon was.
Well, if it's switched, then that would be below the equator. But I don't think you went below the equator. You were maybe as low as 19 degrees latitude.
Yeah.
That's Hawaii, the big island. But you're at 22 on average elsewhere on the islands. And where you are in Arizona is like 33. So it's really not
Right.
that much of a difference.
It was noticeably different, though, when we looked at it.
Yeah.
It was really cool.
But as Daryl pointed out, that angle changed.
That's what it was.
Yeah.
Kind of surprising.
Okay, we got that one covered. Daryl, good job. Let's go.
Hey,
fist bump, Daryl. There you are.
This nebula stuff that you're talking about, can you
Yes.
just for clarification, because there's hydrogen nebulas, dust nebulas, all sorts of, the nebula from a supernova or something. So when does dust become a nebula? Because we're looking now at all these dark nebulas that are
Yeah.
kind of new, and isn't that a dust cloud, or why is it a nebula now? So is there anything that you can explain about the differences of those?
Yeah, actually, and let's do that with this guy right here.
Oh,
This
pretty.
this is the Horsehead Nebula in Orion. We're going to be losing Orion soon, but all of this dust that you see in here is the dark stuff, right? But you also see billowing clouds of hydrogen gas that is glowing. Now, this star is called Sigma Orionis, and Daryl often talks about Sigma Orionis as being one of his go-to stars. It's a cool star. It's got many components, maybe up to 6.
Yep.
Right?
Yep.
Okay.
And it's responsible with its ultraviolet light for causing the illumination of this hydrogen. It's actually causing the hydrogen atoms to ionize. And when those electrons come back into the atom, they give off light. And it's a characteristic orange-red light. All right. But this dark stuff, this is the dark nebula. We would not know this exists if not for the fact that it was being silhouetted by the light that is being generated by the hydrogen atoms that is being created by this bright star right here with its hot ultraviolet energy. So a nebula becomes a nebula when we can see it. We don't know what's there until we see what's there. And this is a whole Orion molecular cloud complex. There's all kinds of molecular compounds in here in the dark cold of space. Remember, we talked about the ice crystals, okay, that were on top of the silicate grains, which form the dust. And so that's what's in this black area here, this dark area in the middle of this area here. This is the flame nebula. It looks like a flame,
Yeah,
So
and
beautiful.
if you zoom in on the Horsehead high magnification images, you can see new stars coming to life inside that dark nebula.
Yep.
Wow.
There's a star right here, okay, for instance, that is really hard to see, but it's there. There's a star here in the end of the snout of the horse. This is really cool.
I hate to interrupt. We're almost out of time,
Yep.
and I want just a minute, okay?
Sure.
Amanda, get ready.
I'm ready.
Somebody, I think it was Andy, joked about seeing Daryl in hot pants. Okay, well,
Oh,
here's
no.
here's about as close as you'll ever get to that. Go ahead, Amanda.
Oh, that's awesome.
I can't unsee that.
SkyTour Radio. where
You
Oh,
look great, Daryl.
I can't unsee that, Daryl.
Ask and you shall
Ah,
receive.
Look at
it's
how
the
beautiful
burning of
that
my
canyon is.
eyes.
Yeah, that's Black Canyon of the Gunnison down in the San Juans.
Oh,
That
beautiful.
is so cool.
So there you go.
You're
And
such a good sport.
It's,
That's awesome.
it's time to end the show.
Yeah.
great.
And then ended on that note. Oh, that was funny though. No, that's great, Daryl. I want to thank you, Daryl. Wonderful as
I don't know
always.
if
Wonderful
Genghis was
dialogue.
talking about our last nebula or Daryl's hot pants there, but mesmerizing view. Thank you all for the support. Thank you for being here again.
Thank you. Yes.
Let's do it again next Sunday. What do you think?
I think it's okay. I mean,
Same
it,
bat time, same bat channel,
Same
horse
bat
head
time,
time,
Robin.
same horse head channel.
Da-da-da.
that's right.
Thanks
right,
for coming,
guys.
everybody.
Thank
Thanks
It
for
was
you.
having
good to
me.
see
Good
you.
night.
Thank
Good
you.
night.
Good night,
Thank you for
Al.
coming
Bye.
along to SkyTour Radio. We'll see you later.
Bye.